As we enter Chapter 4, we're actually entering the second semester of most college-level freshman calculus classes. This is integration, which is taking the antiderivative. So basically, antiderivatives and integrals are the same thing. And integrals come in two flavors, definite and indefinite. Today, we're going to be concentrating on the blue one, the indefinite. The main difference is definite integrals have these little numbers that are hanging on to the top and bottom. They almost look like little ornaments on a tree. This is called the upper limit of integration. This is called the lower limit of integration, not surprisingly. We're going to deal with that later on, but I just wanted to show you that. So the things that you're going to see will look more like this one here, where you don't have anything hanging on the integral sign. The integration symbol up here looks like an elongated S, and that's because it is. It stands for sum, and when you integrate, you're actually adding a bunch of tiny little things together. We're going to see that later. All right. There are two steps to integrating or taking an antiderivative. Before I tell you what the steps are, though, I'm curious to know, if I told you, hey, I've got 3x squared, that is somebody's derivative. Where did it come from? I wonder how many people could tell me that it was x to the third. Because if you take a derivative, 3 times the invisible 1 in front, 3 times 1 is 3, down by a power. Except this time we're going backwards to get to it. And not just x to the third, it could have been x to the third plus 3. Because, when you take a derivative, that plus 3 sort of dies, it becomes 0. It could be plus 33 or 337 or anything. So there could be a constant on the end that we don't know what it is. Okay, so we're going to talk about that later as well. We have to acknowledge that. But how do you go backwards? How do you take an integral or an antiderivative? Well, there's two easy steps. Step number 1 is you go up by a power. And that should make complete sense because after all, when you take a derivative, you go down by a power. So you're heading backwards. And step 2, you want to divide by the new power. And that's it. That's exactly what we did here. Look at this 3x squared that we started with. Let me write that out. 3x squared. But I'm going to go up by 1 power. So instead of 3x squared, it's 3x to the third. So the new power is third power. Now we're going to divide by the new power. Divide by that new power. The 3's cancel, and voila, you got the x to the third. Plus c. And c stands for the mystery constant. We call it the constant of integration. It's sort of like the tomb of the unknown soldier in Washington, D.C. We realize that there was a constant that may have died, but we don't know what it is. Okay, so we have to have the plus c. The plus c is incredibly important later on. In fact, College Board will punish you mercilessly if you forget the plus c. They're going to go nuts on you. So it's important to know about it. All right, let's practice some integration. Here we go. I went ahead and put the steps up in the corner as a little cheat sheet for now, just so in case you need to look at them. All right, and we can integrate term by term as we go. So really, even though there's an integral in front, it's almost like you're taking this integral symbol and you're cloning it. And each part of the problem is getting its own integral symbol, if you will. So you're going to kind of do them one at a time. So let's start out with the 5x to the fourth. The integral there, up by power, so it'll be 5x to the fifth. Divide by the new power. 5's will cancel. Plus, it's not 32x to the seventh, it's 32x to the eighth, because we go up by a power. Divide by the new power, so divide by the 8. And I know that that's going to be 4. I'll clean that up later. Minus 3/4, have to be careful here. X to the fifth is now x to the sixth. We have to divide by the new power. So dividing by 6 is the same thing as multiplying by 1/6. I'm going to prefer that because I have the other fraction next to it. And finally, you don't see this, but this minus 2 up here in black is really minus 2x to the 0. So when you go up by a power, it's minus 2x to the first, and we have to divide by the new power, so divide by 1, which really doesn't do much, but I wrote it anyway. plus c. Don't forget the plus c. When students take tests and quizzes, I actually go around and I'm like, uh-oh, I see a mistake on your paper. I mean, I'm trying my best. And they're like, you do? And I'm like, yeah, I totally see it. And everybody around's laughing and they don't get it. I'm like, oh, dear, no. and even their friends are like, oh, I see it. Ouch. All right, final answer. Let's clean this up. X to the 5th plus 4x to the 8th. We can do a bit of canceling here. That's going to be minus 1/8 x to the 6th minus 2x plus c. And that is our very first antiderivative. We have learned to do basic integration. Here's what's awesome about Chapter 4. Maybe you're a B plus student or a B student or even A minus, and you can never quite get that 100% on things or that high A just because you keep making silly mistakes all the time. That's the story of my life. It's super easy to check an integration problem. Why? Because if you take the answer, you can take the derivative and you should come back to the original problem. Is the derivative of x to the 5th 5x to the 4th? Yeah. 4x to the 8th? Uh-huh. Look at even this harder part. This is minus 6/8 x to the 5th. 6/8, of course, is 3/4. The derivative of negative 2x is minus 2. And the derivative of a constant is 0. Poof. Our answer is correct. And it takes no time flat to check it. Which means that if you're that A minus student or B plus, you could end up with a high A in this chapter if you just simply check all the answers before you turn in a test or quiz. So that is fantastic news. Okay, here's our next integration. Now, people are probably wondering, what's up with this dx at the end? And how come it just sort of disappeared on that last example that you did? You didn't mention it when you went down to the next step. It just was gone. The dx is called the differential. It's the variable that you're integrating with respect to. The reason we need to have it on there, and it is very important, as you will see later on, even when we get into section 4.2 and 4.3, you're going to see why it's important then. But the reason you have to have it is when you get into multivariable calc, when you have more than one variable and you have x's and y's and z's mixed together, and you go up by a power, only the x's go up by a power. The y's and the z's freeze just like they were constants, and you don't divide by their new powers. So you have to have that differential out there at the end. Okay? And when we do this thing called a U substitution later, it's really important to account for the dx. So if you don't do U subs, College Board's going to put fake answers on all the multiple choice questions, and you're going to miss them all. Okay, so the dx does have an important function. We just don't know what it is yet. So let me tell you just cheaply, this is borderline terrible teaching, but I'm going to do it anyway. The dx is sort of like a derivative, and this is sort of an antiderivative, and they sort of kill each other off, and neither one of them makes the journey to the next step. I mean, look at my work for number 1. Neither one of these guys was ever seen or heard from again. Okay? And that's not really terrible teaching. That's really kind of what's happening, although it's not very formalized. So for now, write the dx all the time, but don't worry about what it does quite yet. I promise I will teach that to you in due time. All right, enough talking on my part. Let's actually do number 2. All right, 4/7 x to the 4th. Go up by a power. Divide by the new power. Dividing by 4 is the same thing as times 1/4. What's crazy is we already have some people in class who can probably integrate in their head. Some people are just naturally good at it. It's the same people that tend to be naturally good at mental math, but you never know. All right, let's go to the next term. This will be minus 2/5. Right now it's x to the 1st, so it's going to go up to x squared. Divide by the new power. Again, dividing by 2 is the same as times 1/2. Some canceling is going to occur in both cases. Okay, plus 1/3. Even though this is a fractional exponent, we still go up by exactly 1 power. So I have to add 6/6 to this. So it's going to be x to the 11/6. Strange but true. And we have to divide by the new power. Dividing by a fraction is the same as multiplying by the reciprocal 6/11 plus the constant of integration plus c. All right. My final answer will be right here in this oval. Just need to make it look nice. The 4's will cancel. So will the 2's. So will the 3 and the 6. And now I can go ahead and write it. And that's it. That's our answer. And again, why don't you just check your answer? I mean, you might as well be perfect, right? Is the derivative of this 4/7 x to the third? Yes? Okay, great. The derivative here should be 2/5 x, negative, and it is. If you multiply exponent times coefficient, your 11's are going to cancel out. You'll just have 2/6, which is 1/3 x to the 5/6, and then the plus c disappears because it's a constant. Its derivative is 0. Man, this is great. All right, onward. All right, I'm trying to throw every situation at you I can think of. Let's just see how we do. This is going to be 3 x to the 6th divided by 6. All right, so that'd be 1/2 x to the 6th. Hey, by the way, if you can skip the middle step, good for you. Feel free to do it. I do it all the time. So if you need to write the middle step, there's no shame there. And you might as well get it right? All right, minus 10. I'm going to turn that into 10/1 because I see fractions coming. X to the go up by a power. I have to add 9/9 to that, so it's going to be positive 5/9. I have to divide by that new power. Dividing by 5/9 is the same as times 9/5. I am so nice to you guys, man. It kills me. I always have a little canceling just so that you have your confidence kind of built up. I won't always do that, but I try. That's going to be minus 18 x to the 5/9 power. Oh boy, this is actually x to the negative third in the original problem. And so when you go up by a power, it's going to be x to the negative second. Make sure to go up by a power, don't go down. Negative fourth is going down. Divide by the new power, so that's going to be dividing by negative 2. It's same as times negative 1/2. That looks good. And finally, the integral of 2 is 2x plus 2x. If that didn't make sense, remember this is 2x to the 0, so you're going up by a power, dividing by the new power. So yeah. Plus c, and my answer is already simplified, so all I have to do is just put a big old oval around it, and it's done. Again, you can check it. Going backwards, you can see that it does work. The two that I'm most nervous about are the middle two right here, but 5/9 times 18 is 10. You can see them canceling. So that's great, yeah. And same thing with this part of the answer. Negative times negative is positive. The 2 and the 1/2 will cancel. It's going to go down by a power, which is exactly what we started with. So great. This works with decimals and trig and everything, so I'm just going to see what we know. All right, let's go. This is 4x to the 8th. Divide by the 8th. All right, we'll clean that up later. Minus, again, 10/1. Oh boy, up by a power is going to be x to the negative 2.7. I know it sounds like I'm making this up, but it really does work. You have to divide by the new power, so I'm going to multiply by the reciprocal of that, which is just 1 over negative 2.7. All right. And then plus sine of x. Because remember, the derivative of sine is cosine. We're just going backwards. Plus c. Always plus c. All right, let's simplify. We have 1/2 x to the 8th. Yeah, I'm going to skip that second term. Come back to that last. I'll just copy down the rest so I give my brain a little break here. I'll even make a nice box for the answer. And then I have to come back and deal with this stuff. I know that it's going to be x to the negative 2.7. I just am not sure about what's going to be in front as a coefficient. I do know it's going to be positive because the two negatives will cancel each other out. Boom, Boom. But what's 10 over 2.7? Don't you dare write 10 over 2.7. I will take at least a half a point off, if not a point. Simplify it. 10 over 2.7 is really 10.0 over 2.7. So slide your decimal point over and give me 127ths. And by the way, that will not reduce any farther. If it does, please do. And that is a good looking answer. Well, actually, no, it's not. It looks terrible, but it's right. Yeah, awesome. All right, on this first day of section 4.1, we're going to do 7 examples. So that's 4 down, 3 to go. But on this number 5, I'm going to do it 3 different times, 3 different ways. So I apologize in advance. It's the integral of 3x plus 4 quantity squared dx. One way you could do it is simply FOIL it out. So I'm going to go ahead and FOIL it out right now. Okay, I wrote it twice. That's going to be 9x squared plus 12x. Oh, but here's another 12x. So that's 24x. I'll just combine the like terms on the fly. Plus 16. 4 times 4, 16. Dx at the end. I still have done no calculus. I mean, little kids can FOIL. I'm not doing anything amazing yet. Now I'm going to do the calc. Up by a power, it's going to be x to the third. Divide by the new power, that 9 will turn into a 3. Plus, x becomes x squared. Divide by 2, so that'll be 12x squared plus 16x plus c. And that's the answer to number 5. Woo! All right. That was pretty easy. So FOIL method, not bad. Just FOIL it out and integrate term by term. And anything that's separated by addition or subtraction signs kind of gets its own integral symbol, if you will. All right, let's do this problem again, but this time we're going to use what we call the educated guess and check method, which some people kind of like. I think long term it's a bad idea, but for easy problems like this, it's not bad. Here's what you do. You say to yourself, you're going up by a power. Why don't we just make this a third power? That way I don't have to FOIL it. So up by a power, divide by the new power. But, dividing by 3 is the same as times 1/3. And you're thinking, okay, there's the answer. The problem is, when you go to check your answer, you'll realize that green answer I circled is not correct. Ouch. Here's me checking myself. Power rule. Exponent times coefficient. 3 times 1/3 is 1. Good, that's what I wanted. Stuff. To the go down by a power, it's going to be squared. Hey, we match. Oh, but wait, there's a chain rule. No, but I don't want a chain rule. I'm good. You must take a chain rule. You can't just pretend the chain rule doesn't exist. Times 3. But there's no 3 in front here. And so the green answer wasn't correct. It wasn't right. But we can make it right by doing educated guess and check. Here's what I do. Since it wasn't what I needed it to be, I'm just going to go in here and change that 1/3 in front of my answer to a 1/9. How did you know to do that? I'm guessing and checking, but with a game plan. That's why it's called educated guess and check method. See, now it is a correct answer. Because when I go to check it, 3 times 1/9 would be 1/3 out front. Stuff to the second. Now I welcome the chain rule because the 3's will cancel, and this does match the original problem. So my answer actually has a 1/9 in front. So it's 1/9 quantity 3x plus 4 to the third power plus c. Now here's the bad news, more for me than for you guys. That doesn't look like the answer I got when I FOILed, even though they're both correct. Look at this. Oh my gosh, that's the same? Yeah, it's totally the same. Let me go ahead and just take my answer here in the black rectangle and rewrite it on the other page. Whoa. So as a teacher, how do I know that if I have this on my answer key and you guys have this, I can't mark you wrong. You're not wrong. Well, I would have to triple FOIL it out and then distribute the 1/9 through. Oh my gosh. Can you imagine that? I'd have 3 parentheses. I used to have to do this the long way in the olden days. Now there's Wolfram Alpha that I can use to, thank goodness. But 3x times 3x times 3x is 27x to the third. 1/9 of that is 3x to the third. You can see this is going to work. I'm not going to do all of it. But then some people call me out. They're like, well, isn't 4 to the third 64? 4 times 4 times 4. Won't you get that eventually? I'm like, yeah. And you're going to have a 64/9. Where's the 64/9 in there? It's not there. How can you say that red and black are the same answer? Oh, I'm like, wow. Well, you know what they are, because this red plus C and this black plus C are not the same size. One of them is larger than the other by 64/9. So the 64/9 has been swallowed up by one of the C's. It's in there. It's hiding in there. Because again, C's are mystery numbers. We don't know what they are. Wow. So again, you can get completely different answers than your friends. You can get completely different answers than the back of the book or online answer keys like CalcChat or Slater. So don't doubt yourself. If you're not matching perfectly, you might still be correct. And that's why I like to get into wolframalpha.com and type my answer in, and then it says alternate forms, and sometimes they'll show you other forms. You're like, oh yeah, this is the same thing as the back of the book. So, don't despair. So I wanted you to see that. All right, let's do finally the last way to do this number 5 using what we call U-subs, which is short for U substitutions. And U-subs are actually the best way to do problems. They really are. So what you do is you take this problem and you take the ugliest, nastiest part of it. Now this number 5 is easy, so it really doesn't have an ugly, nasty part in it, but I guess I would say it would be this guts of this parentheses. And you change that to U. And you write a note to yourself. U is the new name for 3x plus 4. So really, this is going to turn into U squared, still with the integral symbol in front. All right, now, what is the derivative of this? What is du dx? What's the derivative of U with respect to x? Again, we need a U equals equation with x's in it, which is what we have. Well, the derivative is 3. Number 4 is a constant. Now, I'm only going to do this one time. I normally don't write this dx here on the bottom. I multiply both sides by it, and I put it here. I just wanted you to see where it comes from. So du is equal to 3 dx. All right, so when I'm normally teaching, here's what's going to happen. Take 2. Hey, u is 3x plus 4. What's du? And you'll say 3. And I'll wait. And there'll be this awkward silence. Crickets. And finally, someone says, dx. I'm like, thank God. All right, yes. Thanks for remembering the dx on the end for me. All right, cool. So here's what's up. You can never, ever, ever have different variables inside an integration. Well, unless you're in multi, then that happens. But if you try it now and you try it in BC, you are doomed to fail. You cannot mix x's and y's and dx's and dy's together. They have to be homogeneous. I'm all for many cultures, one bison. I think it's fantastic, but not here. We want it to be homogeneous and not diverse. We don't want diverse letters when we're taking integrals. We're asking for trouble. So what I need this dx to change to a du is really what I need. But dx and du are not the same thing. Down here it says du is 3 dx. I need a 3 dx. So what do? I just give myself a 3, a times 3 right here. And then this 3 dx becomes the du. Yeah. Wait a second, you just tripled the problem randomly? Yep, I did that. Well, that's not legal. Yeah, you're right, it's not. I just multiplied by 3. Wouldn't life be great if you could just give yourself whatever you need? You're like, I need a $20 bill, and you just, poof, one appears. Or you're like, I need a new car. I need a hot tub. I need a 3. Well, yeah, life's not like that. So because I multiplied by 3, somewhat illegally, I have to make up for it. So I'm also going to multiply by 1/3. There's a times 1/3. And that way I can be like, yeah, I multiplied by 3, but I also divided by 3, so we're even. The 3dx, though, does become the du. It drops down. This is u squared. And by the way, numbers, constants like 1/3, or 5, or even -7, even negative numbers, decimals, as long as you don't have a variable, as long as you don't have trig, if you were a constant, you can move freely back and forth through the integration symbol. So I'm going to land this 1/3 out front. I just think that's a better home for it. And now it's going to drop down to the next step. So again, constants are free to go back and forth. It's almost like an osmosis process, and the integral symbol is a semi-permeable membrane, and the 1/3 can osmosis its way back and forth through whenever it darn well pleases. But things like x's and u's and trig bump against the integral symbol. They can't get through. They boink off of it, and they're stuck where they're at. Okay, so now the problem has become a much nicer looking problem. I can do this. Let's integrate. U squared. It goes up by a power, so now it's u to the 3rd. But I have to divide by the new power. So I have to divide by 3, which is the same thing as multiplying by 1/3. Wait, there's a 1/3 in front already. Okay, cool, come on down. You guys can be friends. There's nothing in between, so throw a multiplication dot there. Obviously, there's no addition or subtraction signs anywhere. Don't forget your plus c, and that's the correct answer of 1/9. There's the 1/9 we got from the educated guess and check method, but we don't have to guess. The u sub is a method that works all the time. By the way, don't put a u in your final answer. I'm going to be like, there's no u's in the problem. Remember, u is something that we cooked up. But right here, because I like to write everything down, I know that u is just, 3x plus 4. And there we go. That's the exact same answer that we just got in green moments ago. Now, right about now, a lot of people are saying, I hate u subs. What a terrible way to do it. Can't I just FOIL that? And the answer is, well, yeah, you could FOIL. Honestly, if I was doing this problem on a test, I would absolutely FOIL it. That was much easier, much cleaner. Well, why are you teaching us u subs then? Why do you say it's better? And I would say back to you, you're going to FOIL this and this, and you got a cube root. You're really going to multiply out 9 parentheses? I doubt it. So yeah, you need a backup plan here. You need to know how to do u subs. Even the educated guess and check people, I'll challenge you right now. If you think you can do this by educated guess and check, give it a shot and let's see if you're correct later on. Maybe get an answer, stop the recording and see what happens. Okay. I'm going to do a u sub. In fact, here we go, number 6. Why not? I'm going to make the u the ugliest, nastiest, most blighted part of this problem that I can find. And to me, it's the stuff inside the cube root. No doubt about it. It's the x plus 1 to the 5th power. Now, choosing the u is an art form in itself, because some people are like, well, why didn't you make it to the 5/3? Or why didn't you put the cube root on it? Wouldn't that be better? That's ugly. I'm like, yeah, that's true, but I knew that I had to take a derivative. I knew I needed a du down below. And the derivative here, remember there's an invisible 1 in front, is 5 stuff to the 4th, got to go down by a power, and I have a 4th power handy. If this 5 had been a 5/3, this would not have gone well. Oh, by the way, dx, don't forget it. Okay, so this is my plan. Again, the whole point of u subbing is to make something that looks ugly look a little bit more beautiful. And in this case, I have the u coming down, and it's going to be u to the 1/3 power. That's what this part is. All right, now the dx has to change into a du. So look over here in green. I need myself a 5 x plus 1 to the 4th dx. I need that before I can proceed. I've got the dx right here. Check. I happen to have an x plus 1 to the 4th just lying around. That is so convenient. But I need a 5 and I have a stupid 8. Now some people are like, well, just multiply by 5/8 and put an 8/5 out front. That's fine. You can do that. But what happens is a lot of people make what I call the reciprocal mistake. They get it upside down. And College Board always makes the reciprocal mistake on their multiple choice test, and they have a fake answer for you. So I find it safer just to kick the 8 out. I'm like, 8, get out. You're in the way. Just move. Osmosis your way through the integral sign. All right, did I mention I need a 5? Yeah, I need a 5. Just give yourself a 5. Go times 5. You can't do that. Well, divide by 5 then. How about out front? And that way you get 8/5 safely. You're not that kid who's always getting the 5/8 out front and you're always upside down all the time. Every class has 1 or 2 people like that in it, and I'm going to try to make sure it's not you. Everything I am circling right now, 5 x plus 1 to the 4th dx, is simply a du. I'll put arrows coming down. All that stuff just changed into this du right here. How do I know that? Well, I wrote it myself right here. It says du is the same thing as all that stuff. Look at how much easier my problem looks now than that awful thing I started with. The cube root and the 4th powers are gone. Now I just have to integrate it. I'll do that in red, up by a power, so u to the 1/3 becomes u to the 4/3 when I add 1. I have to divide by the new power, which means I'm multiplying by the reciprocal 3/4. There's still the 8/5 in front. Come on over, join the fun, come back in again. Being the kind-hearted teacher that I am, I make some canceling just to make you guys feel better about this. Don't forget your plus c at the end. And the answer, once I clean this up, is going to be 6/5. Let me come over here and write it. U to the 4/3 plus c. That is the final answer. Notice you never want to write the u because u is something that we invented. Write what it really is, which is x plus 1 to the 5th. Ooh, this is a little weird. I'm going to have like a double set of parentheses. You know what? No. That's not my final answer yet. I can do better. We know from Algebra 1, a power to a power you multiply. So it's going to be 6/5 quantity x plus 1 to the 20/3 plus c. All right. And since I did a lot of weird stuff, it's probably a fantastic idea if I were to check my answer just to make sure I'm right. So I'm going to do that right now. I've got 20/3 times 6/5. I can do a lot of canceling here. 1 and 2, 1 and 4. That's going to become an 8. That's good because, I need an 8. Awesome. Stuff to the down by a power. So instead of 20/3, it's going to be 17/3. X plus 1 to the 17/3. All right. Is that what I started with? Well, believe it or not, it is. I just disguised it. This was x plus 1 to the 5/3. This x plus 1 to the 4th can be thought of as x plus 1 to the 12/3. And if you multiply those two together, you do get x plus 1 to the 17/3 with an 8 in front. So yeah, believe it or not, our crazy answer is absolutely correct. And you educated guess and check people, I don't know how you did. I don't know, did you get 6/5 quantity x plus 1 to the 20/3 power plus c? Once in a while, you get somebody who could pull that off. But generally, even the very best and brightest in the class are like, I think I'm going to have to u sub. And the problems will get more difficult than that eventually. So pretty soon, everybody will be u subbing it. So again, the goal of a u sub is to take the nastiest, ugliest part of the problem and just turn it into a nice, beautiful u. This is exactly what they did in downtown Cleveland when they made Progressive Field and Rocket Mortgage Fieldhouse. Back in 1994, when they did it, it was called Jacobs Field and Gund Arena. But what they did is they took the nastiest, ugliest, most blighted part of downtown Cleveland, and they're like, right here, we'll build it right here, right along Ontario. In fact, here's what it used to look like. You're coming in on I-77, which is right here. You can see the exit where you loop around. This is Ontario, this street. East 4th used to come all the way through. Here's all the places on East 4th right now. They knocked this out. This was a 7-story, 10-story building. The sign on the side said Sheriff Cold Storage, and there were bars on all the first and second floor windows. Same thing with this piece of junk. They were horrible. They're all boarded up. And this whole area was a surface parking lot. You can see all the cars parked there. And Cleveland, since it snows a lot, as we all well know, you couldn't put numbers on the ground because once it snowed, nobody could see anything. So the numbers hung from like telephone poles and wires, and there were signs everywhere. It just looked horrible. And so what they did is they're like, let's just plow this whole area up, and we'll make a beautiful new baseball diamond, put it right on the corner of Carnegie and Ontario there. That's where Progressive Field is now, with the infield there. And then the Q, or Rocket Mortgage Fieldhouse, is here now. In fact, it even comes all the way out. This is this new glassed-in area that they made, kind of cool looking. Yeah. And then they put the parking garages behind it and stuff. These buildings are all still here, but they got rid of the ugliness and they turned it really beautiful. And that's exactly what we're doing now. We're taking the nasty stuff out and we're replacing it with something nice. Nobody wants to look at this. Get it out of there. Turn it into a U. All right, this will be our last one for day number 1. We're integrating 6 secant squared of x. Now, you may be saying, oh no, trig, but really this is the easiest problem we've done. The 6 can be kicked out. It's just a number. It's out front. You know what the integral of secant is, or secant squared, I should say? Isn't that somebody's derivative? The derivative of something is secant squared, and that something, hopefully you know this from chapter 2, is tangent of x. Oh my gosh. Plus c. There's no work or u subs to do. I just wanted to feed you some trig, because people a lot of times are afraid of trig. That was easy. And if you check yourself, the derivative of tangent is secant squared going the other way. 6 just drops down. That's correct. And that's it for day number 1 of section 4.1. We finally know how to do antiderivatives. And you're going to see that antiderivatives are especially powerful in physics. Anything that moves or has motion, maybe you know the acceleration and you're trying to go backwards to velocity, or you know the velocity and you're trying to write an equation for it, you're going to be integrating. If you want to figure out how to find the area of curvy shapes, that's integration. The volumes and surface areas of things that are oblong or weird shaped, you can figure out that stuff by integration. So there is some power here, even though we're just starting out. So I'll see you guys for day number 2. We'll pick up with number 8 when I see you next.